Hey everyone, it's me, Miss B, and in this video we are looking at the Unit 4 lesson for cumulative practice problems for illustrative math geometry. So this lesson was all about finding ratios in right triangles, and so that's what this homework assignment is going to be about. So starting with the first one, we have angle B is an acute angle in a right triangle. So I'm actually just going to consider this to be like my drawing for that and use that to help. So angle B is an acute angle in a right triangle. Oh, actually, I can't consider that because B is the right angle in this one. So never mind. They're asking, what is a reasonable approximation for angle B if the ratio for the opposite divided by the hypotenuse is 0.67? So they're saying opposite over hypotenuse is 0.67. Now for this assignment, we actually are using a table of values. So a reasonable approximation for the angle, I'm actually going to refer to my table. And so you should have a handout either from your teacher or from me if I'm your teacher. And adjacent, no, this is opposite over hypotenuse. So that is going to be the middle column of values. So I'm looking for 0.67. Now I have two values here. I see 0.643. So 40 degrees would give me 0.643. And 50 degrees gives me a larger number, 0.766. So if the ratio for opposite leg divided by it is 0.67, I'm going to say it's probably in between there, but probably closer to 40. So I would maybe say like 43 degrees might work. So I'll write approximately 43 degrees. Because that's my guess. If you guessed like 45, or as long as it's in between 40 and 50, a little closer to 40, I would think. But in between 40 and 50 should be essentially what you would use for an answer here. Question 2 is what we're going to use for our table here because we are looking at angles A and C. And we're going to fill out this table. Now, they're not giving us what these angles are, but they are giving us the values. So an important piece to remember here is that since A and C are complementary of each other, meaning they add up to 90 degrees, we're going to have basically a diagonal relationship here. For A, the opposite side is going to be BC, and for C, the opposite side is AB. So basically, the adjacent for one is the opposite for the other, which means these values are going to be reversed. So I would know that 0.26 should be my adjacent over hypotenuse for A, because that's what the opposite over hypotenuse is for C. And likewise for the next box, that's going to be flip-flopped from the row for C, so this should be 0.97. Now, the last column has a different relationship because this only uses opposite and adjacent. And since the opposite and adjacent are reversed for this, we're going to reverse this number by doing the reciprocal. So I'm going to plug this into a calculator, but basically I'm going to say that this should be 1 divided by 0.27, and I'm going to plug that into my calculator and find that actual value. So 1 divided by 0.27, and I get that this is around or approximately, and they're rounding to 2 decimal places, so I'm going to round to 3.70. So 3 places after the decimal would give me that. And that's all for question 2. Okay, so I finished recording this whole video and then realized that after question 2, for some reason, it just did not pick up my audio at all. So hopefully this version works. But let's move on to question 3. This one has a little bit more of a conversational back and forth. So let's read through Priya and Han's conversation here. Priya says, I know everything about a right triangle with a 30-degree angle and a hypotenuse with a length of 1 centimeter. Here, look. And so she says the other angle is 60 degrees. The leg adjacent to the 30-degree angle is 0.866 centimeters long, and the side opposite of the 30-degree angle is 0.5 centimeters long. So Han asks, what would happen if a right triangle with a 30-degree angle has a hypotenuse that's 2 centimeters instead? So help them find the missing angles and side lengths in the new triangle, and then explain or show your reasoning. So we know that these triangles are going to be similar because they're going to have the same angles. The only thing that's different is the hypotenuse length. And so we can actually use that as our scale factor here. So my reasoning is going to be that I have a scale factor is 2. Because my new triangle has now a hypotenuse of 2. So what I'm going to do is make a little list over here of the information on my new triangle. Go ahead and write those down. So the other angle is 60 degrees. That stays the same. It is still 60 degrees because dilations preserve angle measure and it's not going to change. But with the leg adjacent to the 30-degree angle being 0.866, this one is going to be affected by the scale factor. So we would do 0.866 multiplied by 2 and get 1.732 centimeters. And then the side opposite being half a centimeter long, we multiply that by 2 and we get 1 centimeter. And those are the missing angles and side lengths. That brings us now to question 4. It gives us an equilateral triangle and it wants us to find the value of x and the measurement of angle B. The second part here, question B, where we have to answer the angle for B, is actually the easiest part. If this is equilateral, all the angles should be 60 degrees and B is not divided or anything, so it's just going to be a flat 60 degrees. Now, finding the height of this triangle will be a little bit different, but we're going to use what we know about 30, 60, 90 triangles to find that. We know that the hypotenuse is twice the length of a side, or the short side. But they're using x to represent the height. I have to use a different variable. I'm going to use y and say that if the short side is y, then the hypotenuse is twice that. That means that since the hypotenuse is 8, the short side is now 4. And the height of this, or the altitude of the triangle, is going to be y times the square root of 3, or just whatever the short side is, times square root 3. So x is equal to 4 square root 3, or 4 root 3. So I'll write that here, x equals 4 root 3. And that's it for question 4. So let's move on to the back. We have here number 5, an equilateral triangle has a side length of 8 units. What is the area? So that was actually like the one we just had, an equilateral triangle has a side length of 8 units. So we want to know the area. Let's just kind of copy this triangle over, and we'll talk about finding the area of a triangle. Okay, so it's not going to be great for equilateral. Still not happy with that, so let's just redo it here. Okay, there we go. I want to be able to move the top a little easier. That should work, and I can even make it a little smaller if I need to. I'm just gonna move it aside. Okay. So, looks equilateral enough to me. Each side is 8, and 8, and 8. Since we know that cutting it in half makes it a 30, 60, 90, 60, and 30, that means that if this was 2x, this part is x, so it is just 4, and our long leg is x root 3, so that is 4 square root 3. Now, to do the area of a triangle, we have to do area is 1/2 base times height. And if you want to be a little sneaky, we actually already have half of the base, and that's 4, because the whole base here is 8. But our height is this 4 root 3. So if you wanted to be a little sneaky, you could just do half of the base, which is 4 times the height, and get your answer. I'll show the whole thing though. This is a equals 1/2 times 8 times 4 root 3. So this is 4 times 4 root 3. So our area is 16 root 3. And that is option A. So option A. That brings us now to question 6. What is the length of the square's side and how do you know? So there is a relationship here between a whole number and then the side length. So if I call these both x, 6 is generally the side we would call x root 2. Since this is a square, I know this is a 45, 45, 90, also known as an isosceles right triangle. And how do I know? Well, it's an isosceles right triangle, but I'm going to use this to find the side length. And since we're doing the same operations every time, in order to solve for x by dividing by square root of 2, we actually really reach a pattern, which is that we have to do that number and multiply it by square root 2 on the top and the bottom. And the denominator becomes 2. So we're going to end up with a number that is half of that whole number multiplied by the square root of 2, because 6 over 2 here would reduce to 3 root 2. So if that's a pattern that you can pick up on, you can use it. Otherwise, if you're more comfortable just doing the solving part every time, I will show the solving part every time, but it's a helpful way to kind of think ahead of time. Oh, I should know this should be, if it's 6, it's going to be half of that, and then times root 2. That then brings us to question 7, which is a step that has a height of 6 inches, and it has a ramp starting 5 feet away, making a 5.9 degree angle with the ground. What can you say about the angle of the ramp if the ramp starts closer to the step? So if I have the same height of something here, and I have something further away, or I have something closer, the one that's further away will have a smaller angle, and the one that's closer will have a larger angle. So you can see this if I kind of lay them on top of each other. This angle, it rises up higher because there's a little gap in between them there. Like you can see this gap in between where the lines are. So that means that the angle will get bigger the closer that it is. Oops. We'll just hit undo to move it over there. So the angle will get bigger the shorter that the ramp, or the closer it starts to the actual step. So in this case, I'm going to say that while that distance is going to decrease, the angle itself is increasing, so the angle would increase. That brings us to our last question. This quilt is made of squares with diagonals, and then they're giving me the length of BD. So they said the length of BD is 4, and BD is right here, so that's the diagonal of the whole square. That's 4, and they want to find the length of AE. That is this piece here. And then they want to find the area of the square ABCD, so that just means I'm going to need one of the entire side lengths. So I'll just use, not my eraser, I will use BA as, I guess, what I'm looking for my side length. So if I have 4, the same idea, I know I can use the pattern. If I have a whole number for my hypotenuse, I can divide it by 2 and then multiply it with the square root of 2. But I can also just use the Pythagorean theorem, because if you remember, we had a question like this on the homework before. This is from Unit 3, Lesson 12. They were just expecting you to use the Pythagorean theorem. So you could say that like x squared plus x squared equals 4 squared. And so if I'm calling this entire side x, the area is actually going to be x times x, which just is x squared, because it's the length times the width. So I can do a little bit of a kind of trick here too. But I will want to find AE, which is going to be half of whatever x is. So I do want to find the whole value of x. But either way, this would make 2x squared is 4 squared, which is 16. Divide by 2, you would get that x squared equals 8. So that means the area would be 8. And now I want to find x. So you're going to have to take the square root. I'll do this in a different color to show my step. So x is square root of 8. And then half of that would be square root of 8 over 2. Square root of 8 actually is 2 root 2 over 2. And so this would reduce and give us square root of 2 over 2 for the length of AE. And then that's it. So that's this entire assignment. The area of the square is 8, and that length is 2 root 2, and that's all they wanted for this question, and that was the last question we had. So thank you for sticking with me. Hopefully my audio recorded appropriately this time, and this has been the cumulative practice problems for Unit 4, Lesson 4 of Illustrative Math Geometry.